Okay, let's unpack this. Imagine having like a front row seat to the birth of modern physics, getting to know the brilliant, sometimes quirky, sometimes difficult minds who really shaped our world.
Yeah.
Today, we're diving into this extraordinary set of reflections from Professor Yang Zening, a Nobel laureate himself, mind you, on the great physicists of the 20th century.
And what's so fascinating here, I think, is that it's not just, a history lesson. We're getting this deeply personal account.
Right.
It's filled with anecdotes, insights. It paints these really vivid portraits of these giants. You get everything from their groundbreaking theories to their everyday quirks.
Mm-hmm.
This deep dive is really about understanding that human element behind the science, behind the revolution.
Exactly. So our mission today is to pull out those powerful nuggets of knowledge. What defined these revolutionary scientists? How did their personalities influence their work?
And what lessons did Professor Yang take away from interacting with them?
Especially lessons for you, our listener. What can we all learn?
Right.
So the 20th century, it really kicked off with a bang in physics, didn't it? Fundamentally reshaping how we saw the universe.
Oh, absolutely. Professor Yang highlights three massive conceptual revolutions just in the first, 30 years?
Yeah.
First, you had the special theory of relativity in 1905 that completely changed our ideas about space and time, making them relative to the observer.
Okay.
Then general relativity followed in 1915, showing gravity isn't really a force, but the curvature of space-time itself. Wild stuff.
Still mind-bending.
And then, between about 1913 and 1927, we saw the development of quantum mechanics, unveiling these bizarre probabilistic rules that govern everything at the atomic level.
And these weren't just abstract ideas floating around in academia. Their influence is, well, it's profound. It touches our daily lives.
Totally. I mean, think about it. No quantum mechanics, no semiconductors.
Right, and no semiconductors, no modern computers. Our whole digital world just wouldn't exist.
It'd be a completely different reality. And what's really remarkable is Professor Yang's unique perspective here.
He knew them.
He knew so many of them, often when they were, 20 or 30 years older than him. He didn't just meet them. He knew them well, had conversations, discussed physics, life.
He paints such compelling portraits. Let's start with Wolfgang Pauli, often called the conscience of physics. Now, Pauli famously discovered the exclusion principle, right?
Yeah.
This fundamental rule about how electrons behave in atoms.
Huge contribution. Even if, as Yang notes, Pauli didn't really see himself as a revolutionary, more of a scholar.
But his mathematical ability.
Wow.
Oh, astonishing. So Heisenberg proposes quantum mechanics in 1925, right? And it's using this new kind of baffling mathematics.
Very abstract.
Very. And Pauli, within 2 months, manages to use it to solve the hydrogen atom spectrum problem.
2 months.
2 months. It just stunned everyone. And it was crucial validation for Heisenberg's theories, showing they matched actual experimental results.
That's incredible speed, incredible insight. But despite that brilliance, Yang recounts Pauli had this reputation for being,
extremely rude was the phrase Yang used, even though his work was totally uncompromising.
Yeah.
Yang even shared this personal story from 49 when he was a postdoc. Pauli would apparently visit their office every day at 10 a.m.
Oh, boy.
And if they hadn't made progress, he'd make these sarcastic remarks. Yang said he and his friend became genuinely afraid to see Pauli.
Wow. How do you square that? Someone so difficult, yet so respected.
It must have been the sheer force of his intellect, the quality of the work.
Got to be. But yeah, those personal interactions.
Yeah.
Harsh. Yang mentions he told one assistant, Fiskov, essentially that he should have kept the previous assistant, Beta, because Beta was better.
Ouch. That's rough.
Really highlights a difficult style. But interestingly, later in life, just months before he died, quite young, at 58, in 1958, Pauli reflected on his youth. He admitted he thought he would be the one to solve the biggest problems, but acknowledged others did. He called himself just a scholar, not a revolutionary. And even said, I was really stupid when I was young.
That's quite a turnaround. Quite a humbling self-assessment. Okay, so from the uncompromising Pauli, let's move to someone seemingly quite different. Enrico Fermi.
Ah, Fermi.
Born in Italy, Nobel Prize in 38, then moved his family to the U.S., became a citizen, made huge contributions to the American atomic weapons program, and he was actually Professor Yang's teacher.
Right, and the description of Fermi is consistently solid and steady. In life, in physics, just universally respected. Students, colleagues, even government officials.
That character really comes through in an anecdote Yang tells. Oppenheimer, who was chairing the Atomic Energy Commission's advisory committee.
The big deal position.
Huge. He kept trying to get Fermi to renew his term on the committee, but Fermi refused.
Why?
He basically said he couldn't guarantee his opinions were correct on many of the issues they'd face.
Wow. That's integrity and humility,
Yeah.
especially for that level.
Absolutely. And his physical stamina seemed to mirror his intellectual approach, too. Yang talks about the summer of 1954. Fermi, despite having undiagnosed esophageal cancer, which is just tragic,
Yep.
he was incredibly active, gave 3 excellent lectures. And Yang recounts swimming with him in the Atlantic. Fermi had this steady, long-distance style, just kept going.
A perfect metaphor for his approach to work in life, wasn't it? Solid, steady, persistent.
Exactly. Okay, next up, Werner Heisenberg. No, he's more of an enigmatic figure, wouldn't you say? A visionary, certainly.
Definitely. Proposed quantum mechanics at just 24. I mean, that's undeniably a revolutionary, historic contribution.
But Yang suggests his actual articles were, well, a mixed bag. What exactly does he mean by that? How could they be both brilliant and contain rubbish?
Yeah, it's a fascinating point. Yang says his papers had these incredible, insightful insights, but they were often mixed with many erroneous views, sometimes just unclear.
It's like diamonds in the rough.
Sort of. Heisenberg was brilliant at developing new, maybe immature ideas, pushing into uncharted territory, and when you do that, well, not every path you explore is going to be the right one. Some are dead ends, some are just wrong.
That makes sense. Yang mentions Heisenberg's own analogy for discovery.
The mountain climbing one?
Yeah, climbing a mountain in a fog, you're trying to get to the peak, can't see clearly, then suddenly this vague image appears. Oh, that's the big rock I'm looking for.
Right. And in that instant, even though it's fuzzy, you suddenly know the way forward.
Yang says that perfectly captures Heisenberg's own breakthrough at 24. That sudden, illuminating glimpse through the fog.
He also sounds like he was pretty competitive.
Oh, yeah.
Became director of theoretical physics at Leipzig University at just 26. Apparently, he dominated the department table tennis games. Until a Chinese postdoc, Zhu Peiyuan, who happened to be a family friend of Professor Yang, arrived in 1928. Suddenly, Heisenberg was runner-up.
That's a fantastic detail. Love it. Okay. And then there's Paul Adrien Maurice Dirac, an architect of elegant truths.
Dirac. As famous as Heisenberg, equally decisive contributions to quantum mechanics, but his style, completely different. Yang describes Dirac's articles with phrases like wonderful beauty, a stroke of genius. He says they were original, clear, direct, and without impurities, like autumn water articles that are not stained by dust.
Oh, that's almost poetic.
Isn't it? The feeling after reading Dirac, Yang says, is that there's nothing else you can do. Everything correct is explained so directly, so perfectly, there's no ambiguity, no room for improvement on that specific point.
Which is the absolute opposite of reading Heisenberg, right?
Exactly. Reading Heisenberg, you realize there are still many things to do. Mainly, you have to sift through it, figure out what's brilliant insight and what's, well...
The rubbish.
The rubbish, yeah. Discerning right from wrong within his work. Two giants, two totally different ways of thinking and writing.
Incredible contrast.
And it's also worth noting, Pauli, Fermi, Heisenberg, Dirac, they were all born right around the same time, 1900, 1901, 1902.
A shared generation.
A generation that just fundamentally changed physics. Yang mentions attending many centenary celebrations for their births recently.
What an era. Okay, let's bring in some other key figures Yang reflects on. Edward Teller, for instance, often called the father of the hydrogen bomb.
Right. Teller had a really profound influence on Yang, particularly because of his very strong intuition.
Yang shares that famous description of Teller having at least 10 ideas a day.
And 9.5 of them were wrong.
Yeah. But, as Yang points out, even getting half a correct idea every day, that still made him an incredible scientist.
That's a pretty good batting average in theoretical physics, actually. Half a good idea a day. Most would take that.
For sure. And Teller's approach was different, too, especially compared to maybe a more traditional, cautious academic style. Yang knows he was not afraid to tell people he was wrong.
That's interesting. How did that play out?
Well, apparently he'd just grab you in the hallway, start discussing ideas, actively listen to objections if they were reasonable, invite collaboration. So it's very dynamic, very open to iteration.
Which ultimately led to really important contributions, despite the high error rate, maybe because of it.
Possibly. Yang also touches on Teller's biography, published when Teller was in his 90s. It got heavily attacked by the U.S. media, largely due to the Oppenheimer conflict.
Right, that was very contentious.
Very. But Yang says he read it and found it very well written and nothing exaggerated, just offering his perspective.
Then there's, of course, Albert Einstein, a figure who maybe needs no introduction, but perhaps is misunderstood.
Yang seems to think so. When Yang arrived at the Institute for Advanced Study in 1949, Einstein was already the most famous physicist on the planet, but he'd retired.
Having already proposed, as Yang puts it, 2.5 of those 3 major revolutions we talked about.
Exactly. But Einstein spent the last decades of his life working on unified field theory.
Which at the time was seen as kind of fringe, unrealistic.
Totally. Yang says the postdocs back then generally avoided disturbing Einstein because they felt his work wasn't really going anywhere relevant.
But fast forward a few decades.
And that direction, unifying the fundamental forces, is now arguably the mainstream direction of theoretical physics.
Talk about being ahead of your time. Wow.
Yang shares a nice personal moment, too, taking his eldest son, Yang Guangruo, to meet Einstein during Einstein's daily walk to the Institute. There's even a photo.
Oh, that's lovely.
But he also pushes back against the common image of Einstein. You know, the sort of benevolent, absent-minded professor.
The charitable and nonchalant image.
Yang says that's completely wrong. He found Einstein to be very critical of human nature, actually quite critical of everything in the world.
Really? That's surprising.
Yeah. He even used this analogy comparing the ocean, sometimes calm and kind, sometimes turbulent and terrifying to humans, noting critically that both are just made of water.
That is a surprisingly sharp, almost cynical view from the popular image of Einstein.
It is. Okay, let's talk Niels Bohr, the philosophical architect of quantum mechanics.
Bohr, huge figure. Yang credits him with essentially giving birth to quantum mechanics back in 1913, applying Planck's quantum ideas to atomic structure, truly groundbreaking.
Yang knew Bohr well personally, but found him difficult to talk to.
Why was that?
Apparently, Bohr had a very low voice and spoke with a Danish accent that Yang described as kind of mumbling.
Okay. Communication barrier.
A literal one. Yang recounts visiting Bohr's home, Carlsberg Castle no less, in 1957. Bohr spent over half an hour discussing non-conservation of parity, this really fundamental concept about symmetry.
Which Yang and Lee had just won the Nobel for, overturning the assumption of parity conservation.
Right. But Yang admits, after half an hour of Bohr talking about it, he had no idea what he was talking about because he just couldn't understand him clearly.
Oh dear. Despite the language barrier, though, Bohr's philosophical outlook was clearly profound.
Absolutely, that famous quote. The deepest truth is that both the truth and its opposite are true. Very dialectical.
And there's that great anecdote about the horseshoe hanging outside his office door.
Oh yeah, tell that one.
Well, a friend saw it and questioned him, like, surely you don't believe in a superstition like a horseshoe bringing good luck.
And Bohr's reply.
Bohr said, of course I don't believe it, but, he added, I know that even if you don't believe it, it's still effective.
Huh. That's brilliant. Perfectly captures that blend of deep thought and maybe a touch of playful paradox.
Exactly. And speaking of gatherings of great minds, Yang mentioned the 1953 Japan conference.
Right, the big post-war scientific conference organized by Nobel laureate Yukawa. Lots of international scholars wanting to help Japan rebuild its science.
And get this, Yang looked at the group photo from that conference years later. He counted 17 future Nobel Prize winners in that single photo.
17. That's incredible foresight from Yukawa, the organizer. Just unbelievable talent identification.
Truly amazing.
So as we kind of reflect on all these incredible figures, Yang also offers some really profound wisdom looking both outward and inward. He talks about China's scientific development, for instance.
Yeah, he acknowledges that, okay, maybe China's physics still lags behind the absolute cutting edge in some areas, but the historical trajectory, he calls it, amazing.
He points out that when he was born, maybe 80 years before he was reflecting on this, modern science in China was essentially zero.
Right, starting from scratch in the early 20th century.
Yet, look at the progress. Developing an atomic bomb just 15 years after 1949, then a hydrogen bomb only 2.5 years later.
Yang calls that pace unprecedented in human history and almost unbelievable to scientists around the world. He highlights Deng Jiaxian as a key figure in that incredible achievement.
And reflecting on his own career, Yang is remarkably humble. He attributes much of his success simply to luck.
Luck? How so?
Well, growing up in an academic environment at Tsinghua, getting to attend top universities like Southwest Associated University during the war, then the University of Chicago.
Right place, right time.
And crucially, entering a new, developing field, high-energy physics, particle physics. right as it was taking off.
So he could grow with it at the same time, as he put it.
Exactly. He called that the most fortunate thing, feeling like he just caught the wave perfectly.
Which leads directly into his advice for young scientists, doesn't it?
It really does. He stresses that the most important decision for a graduate student is choosing a field. Not just any field, but one with development, one that's growing, rather than one that's sort of dying.
You need foresight. You have to extend your antenna, as he says. Look ahead, try to figure out which research directions seem promising, reliable, likely to develop further.
And he offers a really crucial strategy here, the 2 feet on 2 different boats approach.
Meaning?
Diversify. Don't put all your intellectual eggs in one basket. Have interests or skills in slightly different areas within your broader field, or maybe even adjacent fields. It mitigates risk.
That seems particularly relevant when he discusses something like string theory.
Absolutely. He acknowledges it's a huge area in theoretical physics, attracts many of these smartest graduate students because it's so intellectually stimulating.
And the goal is huge unifying gravity, Einstein's general relativity, with the other 3 fundamental forces described by gauge theory, the ultimate unification.
But there's the dilemma.
Right. Despite decades of intense work, brilliant minds, countless papers, Yang points out there's still no real connection between it and reality. No experimental proof, no testable predictions that have panned out.
Which is, as you said earlier about Heisenberg, unusual in science. Usually theory and experiment dance together more closely.
It's a very unique situation. So Yang's counsel isn't, don't do it. He says if you're drawn to it, pursue it. But
You better understand that it has its risks.
exactly, and that's where the 2 feet on 2 different boats comes in again. Maybe work on string theory, but also keep skills sharp in another area of physics, perhaps one more connected to experiment.
So you don't end up completely empty, as he puts it, if the field doesn't ultimately connect with physical reality. It's like intellectual hedging.
A very pragmatic piece of advice, grounded in his long experience.
And finally, maybe the most powerful reflection. When asked about the single most important thing he felt he'd done in his life, his answer wasn't about physics.
What did he say?
He said, I think my most important contribution in my life is to help the Chinese people overcome the feeling of being inferior to others.
Wow, that's profound. Shifting from the scientific to the deeply human, the societal.
Really puts his entire life and work into a different kind of perspective.
So, thinking about everything we've discussed, what does it all mean?
Well, it seems clear the grand story of 20th century physics isn't just equations. It's this rich tapestry woven with individual genius, yes, but also starkly different personalities, clashes, collaborations, a surprising amount of human drama.
Absolutely. From Pauli's sharpness to Fermi's unwavering integrity, the totally contrasting brilliance of Heisenberg and Dirac, these personal stories really illuminate the process of discovery itself.
And connecting that to the bigger picture, it just underscores how breakthrough science isn't made in a vacuum. It's profoundly shaped by the people doing it.
Right. And Professor Yang's own reflections offer such a potent lesson. Intellect and hard work are vital, obviously, but recognizing opportunity, timing, even strategically diversifying your bets that can be just as crucial for making a real lasting impact.
Which brings us to the really interesting part for you, the listener. Thinking about the huge challenges and all the emerging fields in our world today, how could our current leaders, innovators, maybe even you in your own work, benefit from these diverse approaches? The sometimes contradictory but ultimately effective methods we've explored.
Yeah, what's your 2 feet on 2 different boats strategy for navigating the complexities you face? Something to really mull over.